We are going to solve Additional Mathematics, Paper 1, Practice Paper for examination from 2025. Duration of the paper is 2 hours and the total mark for this paper is 80. Question number 1. The curve y is equal to 2x squared plus k plus 4 intersects the straight line y is equal to k plus 4x at two distinct points. Find the possible values of k. If the curve intersects a line at two distinct points, it means that b square minus 4ac is greater than 0. Now, there are two equations, so we will substitute this value of y to this equation. So this will become 2x squared plus k plus 4 is equal to k plus 4 x. 2x squared plus k plus 4 is equal to kx plus 4x. Then 2x squared plus k plus 4 minus kx minus 4x is equal to 0. We'll rearrange 2x squared minus kx minus 4x plus k plus 4 is equal to 0. Now the value of a is 2. The value of b is minus k minus 4. C is k plus 4. As the curve intersects line at two distinct points, we have to use b square minus 4ac is greater than 0 to find the values of k. So now we will substitute here b minus k minus 4 into 2 into k plus 4, which is greater than 0. We have to expand this using identity. So if both the terms are negative, it means that all the terms will be positive when you will apply the identity. So this will become k square, square of k square, plus 2 multiplied by k multiplied by 4 is 8k. 4 square is 16. Then minus 4 into 2 into k is minus 8k. Minus 4 into 2 into 4 is 32. Minus 32. Plus 8k and minus 8k will be cancelled out. We'll be left with k square minus 16 is greater than 0. In inequalities, we cannot take the square root, so we will apply here a square minus b square is equal to a minus b, a plus b. So k square minus 4 square is greater than 0. So we have k minus 4 and k plus 4, which is greater than 0. Now we'll take out critical values of k. K minus 4 is equal to 0. K plus 4 is equal to 0. K is equal to 4 and k is equal to minus 4. So now we will sketch a curve. We have here minus 4, here 4. The curve is to be somewhat like this. We have to consider the part which is above x-axis. So it means that we have to consider this part. We have to tell the values of k on this part of the curve, which is k is less than minus 4. And on this part of the curve, the values of k are greater than 4. K is greater than 4. Question number 2. The diagram shows the graph of y is equal to f of x, where f of x is a cubic polynomial. Find f of x, giving your answer as a product of linear factors. Now, first of all, we will find out x-intercepts. So we have here x is equal to -5, x is equal to -1, and x is equal to 2. Then y-intercept is 5. Now, we will make factors from this. X plus 5. We have x plus 1. And we have x minus 2. So, f of x is equal to x plus 5, x plus 1, x minus 2. Now, when we multiply constant terms, then we get y-intercept. So, when we will multiply 5 by 1 and by minus 2, we are getting minus 10. But the y-intercept which is there in the graph is 5. So, we need to multiply this by 1 upon 2 so that we get 5. But still, 5 multiplied by 1 multiplied by minus 2 is minus 10, and minus 2 divided by 2 is minus 5. But here it is positive, so it means that we have to put here minus sign as well. So, this is the required f of x. B part, write down the values of x such that f of x is less than 0. F of x is less than 0, it means that we have to consider the part which is below x-axis. This part and this part. On this part of the curve, the values of x lies between -5 and -1. The values of x on this part of the curve are greater than 2. So, this is the required answer. Question number 3. Solve the inequality absolute of 5x plus 4 is less than or equal to absolute of 2x minus 3. Now, we have to take 5x plus 4 is equal to 2x minus 3. And another time, we have to take 5x plus 4 is equal to minus 2x plus 3. We are taking out the critical values. 5x minus 2x is equal to minus 3 minus 4. So, 3x is equal to minus 7 and x is equal to minus 7 upon 3. 5x plus 2x is equal to 3 minus 4. So, 7x is equal to minus 1 and x is equal to minus 1 upon 7. These are the critical values. These are the values where these two graphs intersect each other, right? So, these are the points. This is minus 1 upon 7 and this is minus 7 upon 3. Now, we have to consider the part where 5x plus 4 is lesser than 2x minus 3. So, this is the graph of 2x minus 3, absolute of 2x minus 3, and the red one is the graph of 5x plus 4. So, we have to consider the part where 5x plus 4 is lesser than 2x minus 3. So, we have to consider this part of the curve. And the range of values of x for this part of the curve is x is greater than or equal to minus 7 upon 3 and less than or equal to minus 1 upon 7. Question number 4. The function f is defined as f of x is equal to x squared plus 2x minus 3 for x is greater than or equal to minus 1. Part A. Given that the minimum value of x squared plus 2x minus 3 occurs when x is equal to minus 1. Explain why f of x has an inverse. So if we change it into completed square form, we will be getting x plus 1 whole square minus 1 square minus 3. So which is x plus 1 whole square minus 4. So minus 1 comma minus 4 is the turning point, right? The domain is x is greater than or equal to minus 1. So it means that these are the values of x which need to be considered while considering this function. If we see the graph for the values of x greater than or equal to minus 1, it is a one-to-one function. We can write that f of x is a one-to-one function because of restricted domain. That is, x is greater than or equal to minus 1. This graph was drawn for your understanding. B part, on the axis below, sketch the graph of y is equal to f of x and the graph of y is equal to f inverse of x. Label each graph and state the intercepts on the coordinate axis. Now, whenever we have to draw the graph of function and inverse function, then we have to draw a line of y is equal to x. As it is there in the question that state the intercept on the coordinate axis, it means that we have to take out y-intercept as well as x-intercept. So we have here x squared plus 2x minus 3 which is f of x. So if we take x as 0, then y is equal to minus 3. So y-intercept is 0 comma minus 3. For x-intercept, we have to take y as 0. So then we will do middle term breaking. X squared plus 3x minus x minus 3. So x plus 3 minus 1 is common, x plus 3. So we have x minus 1 and x plus 3. So we have two x-intercepts. X minus 1 is equal to 0, x plus 3 is equal to 0. So x is equal to 1 and x is equal to minus 3. We will mark these x-intercepts and y-intercepts on this grid. We have minus 1 here, minus 2 here, minus 3, 1, 2, 3, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. So the turning point is at minus 1 comma minus 4 over here. Then at 0 comma minus 3, it is y-intercept and x-intercept is at 1. So now we can sketch the curve like this. This is the graph of y is equal to f of x. Now we have to draw the graph of f inverse of x. We'll take out the coordinates of f inverse of x. For the graph of f inverse of x, the x coordinate become the y coordinate and y coordinate becomes the x coordinate. So we have here -1, -4. So this will become -4, -1. This is 0, -3. So it will become -3, 0. This point is 1, 0. So this will become 0, 1. So now we'll mark the points. We have -4 over here. So -4, -1 is over here. -3 is here. -1 is here. And the graph will intersect this line y is equal to x at this point. So we will sketch a curve now. The graph of f inverse of x is the mirror image of graph of f of x. Question number 5, part A. Show that sin x tan x upon 1 minus cos x can be written as 1 plus sec. First of all, we can change this tan x to sin x upon cos x. So sin x multiplied by sin x upon cos x multiplied by 1 upon 1 minus cos x. We can write this as separately. Now we will have here sin square x cos x 1 minus cos x. Now sin square x can be written as 1 minus cos square x 1 minus cos square x can be factorized using a square minus b square. So this will become 1 minus cos x 1 plus cos x upon cos x 1 minus cos x. So 1 minus cos x and 1 minus cos x can be cancelled out. So we will be left with 1 plus cos x upon cos x 1 upon cos x plus cos x upon cos x. So this will become sec x and this will become 1. So we have proved that this can be written as 1 plus sec x. Part B. Hence show that d sin x tan x upon 1 minus cos x dx can be written as tan x sec x. So it means that y is sin x tan x upon 1 minus cos x. And we have proved in the previous part that this is equal to sec x plus 1. So we can write it as 1 upon cos x plus 1. We can further write it as y is equal to cos inverse of x plus 1. Now, when we will differentiate, the power, so it will become minus 1. So this will become cos power minus 2x, and then we will differentiate this function, so this will become minus sin x. When we'll differentiate 1, it will be 0. So minus multiplied by minus will become plus, and we can write it as sin x upon cos square x. Then we can write sin x upon cos x and 1 upon cos x. So sin x upon cos x will become 10x, and 1 upon cos x will become seconds. So we have proved that this can be written as 10x seconds. Question number 6. Solve the following simultaneous equations. Log 3 x plus y is equal to 2. So we can write this as x plus y is equal to 3 squared. So x plus y is equal to 9. Another equation is 2 log 3 x plus 1 is equal to log 3 y plus 2. We can make this 2 as power of x plus 1. So log 3 x plus 1 whole square is equal to log 3 y plus 2. We have here 2 logs of the same base, so we can cancel out this. So we have here x plus 1 whole square is equal to y plus 2. We can expand it using identity. So x square plus 2x plus 1 is equal to y plus 2. We can make y the subject from this. So y is equal to 9 minus x, and we can substitute over here. So x square plus 2x plus 1 is equal to 9 minus x plus 2. X square plus 2x plus x will be plus 3x. 9 plus 2 is 11, and 1 minus 11 would be minus 10. So x squared plus 3x minus 10 is equal to 0. Now we can do middle term breaking. Plus 5x minus 2x plus 10 is equal to 0. X is common. X plus 5 minus 2 is common. X plus 5 is equal to 0. We have two factors, x minus 2, x plus 5. So x minus 2 is equal to 0, and x plus 5 is equal to 0. So we have got one of the value as 2, another value as minus 5. If we'll substitute here 2, this log will become log 3 of 3. But if we'll substitute here minus 5, then minus 5 plus 1 will become minus 4. So we cannot have negative sign here. So this value is to be rejected. So now we'll substitute this value of x in this equation to find out the value of y. 9 minus 2, which is 7. Question number 7. When y cube is plotted against ln x, y cube is plotted against ln x, a straight line graph is obtained. The straight line passes through the points 1, 5. If this point is 1, 5 and 6, 15, and we consider this point as 6, 15, find y in terms of x. So first of all, we can make the equation for this line whose coordinates are 1, 5 and 6, 15. So we need to take out m. M is equal to 15 minus 5 upon 6 minus. So the gradient is 10 upon 5, which is equal to 2. Now we'll take out c. For c, we will substitute the coordinate and this gradient in the general form of the equation y is equal to mx plus c. So we can take this coordinate 1, 5. 5 is equal to m is 2, x is 1 plus c. So c is equal to 5 minus 2, 3. Now we can write the equation y is equal to mx plus c. We can substitute the values here. In place of y, we have y cubed, so we can write here y cubed. Gradient is 2, so we can write here 2. In place of x, we have ln x, so we can write here ln x. C is 3, so plus 3. Now we have to write y in terms of x. So it means that we have to remove this cube from here. So if we have to remove this cube here from here, we will take cube root on both the sides. So this will become cube root of ln x plus 3. And here cube root and cube will be cancelled out. So we have equation y is equal to cube root of 2 ln x plus 3. Part B. Given that y is greater than minus 1, find the corresponding values of x. So if y is greater than minus 1, it means that cube root of 2 ln x plus 3 is greater than minus 1. So now we can take cube on both the sides. So we will have 2 ln x plus 3 is greater than minus 1. 2 ln x is greater than minus 4. ln x is greater than minus 2. Now we can consider ln x is equal to minus 2. So x is equal to e power minus 2. So the critical value of x is e power minus 2. So now we can write x is greater than e power minus 2.